Dear students, good morning. How are you? Here, Dr. Math speaking with a new lesson. So today we're going to talk about how can we use what we already learned for modeling. Sometimes we just have something in life that it's happening and we want to find a function so we can predict the future, and we have the data, okay, and we need to find the function. Okay, so here we go. Here we have the how periodic functions, sines or cosines, okay, these are the parameters that we might need to find, okay, A, B, C, and D. Now, the first thing you have to know is what each one of these represents, okay. This would be, D would be vertical shift. Let's just graph a simple sine function, okay? A sine function will repeat every 360, so every 360 degrees. So here we would have a full cycle. In the middle would be 180. It's here, okay? And here we would have +1, and here we would have -1. So a sine would start at 0, 0, okay, and would go up until 1. Then it would pass 180 through 0, and then would go to -1, and it would end at 360. So let's use another color, maybe this one. So it would go like this. Go up, then it would cross the x-axis, would go down to -1, touch -1, and then go up again. And this is a full cycle. If you look, here it's going up. Here would still go up, right? So here we have ended a full cycle, and here would go down, right? So this is how the sine behaves. Now, this vertical shift means that if we apply it to a sine, this would be just a regular sine of x, right? So now if we apply D, if we add 3 here, what it would happen is that all this function would go up 3 times, okay? That's what we call vertical shift, okay? While this one, C, it's an horizontal shift, horizontal shift. That means that if we apply a value here, like 60 degrees or -100 degrees, this would make this function move right or left, okay? If it's positive, the shift would be towards the left. It's not intuitive. You would think it would work the other way, but it does work this way, okay? So it's positive, it's left. If it's negative, it's right, okay? Now B, it's a parameter that affects the period, okay? It affects if the function would, the frequency of the function would let me maybe just graph it. I think it would be simpler. B would affect like if the function would be like this, or instead would be like this. So it affects the frequency and the period because they're related. And then this affects the amplitude, okay? This is the amplitude. So if you think about waves, the amplitude would be how high is the wave. It would be this value here would be the amplitude. Okay, what this amplitude is big compared to this one, for example, right? They have the same frequency here, but the amplitude is different. Okay. So now, now that we know that, and how to compute b, by the way, how to compute b. B, will compute b. If it's in radians, we'll use 2 pi over t. T stands for the period. Okay. But in degrees will be 360 over t. Okay. Over t is also the period. What's the period? The period, and we'll write it here. The period is how long does it take for a full cycle? Okay, so let's think what is a full cycle, and that's important. People get confused about this. What's a full cycle? Well, a full cycle would be when we found ourselves again to the same point. For example, here. Imagine here. What would be a full cycle from here? Well, let's think about it. If I go down, right, and then I go up all the way, now here, I will be at the same point as here. And what I mean at the same point is that if I keep going, it will happen the same thing. It will just go down. Both of them will go down. You see that? Right? So, it will be the same thing. For example, in this one, imagine that I ask you here, what would be the same point? When do we have a full cycle? Some people would say, okay, here. No, here it doesn't, because here, if I keep going, this one will go up while this one will go down. Correct? So this one would be a similar point. Would be here I go up and here I go up, right? So what I mean by this is that from here to here we have a full cycle. We will find ourselves at a similar point. Okay? So then to compute the period is the distance from 2 points that are a full cycle. So from here to here, this will be t, the period. And how much is the period for this function? It's 180, right? 180. I should ask you, Mick, right? You're bored here. Yes, you should ask me. Okay. Next one, okay? So t here it's 180. So if I want to find the function for this graph, okay, and I look up here to A, B, C, and D, I have to find A, B, C, and D for this graph. So let's start with A. How much is A? How much is the amplitude? Well, the amplitude is always from the middle of the graph to one of the top or bottom values. So it would be from here, right, to up here. That's from the middle of the graph, from the axis to the top, and this is the amplitude. And how much is it? Well, it's 1, 2. Here we have, don't count squares. Just look here at the scale, okay? So this is 2. So from 0 to 2, that's 2. So the amplitude is 2. I'll write it here. The amplitude is 2. Then how much is B? B, we are doing degrees, so the formula is 360 over t. As t is, as we said, 180, 360 over 180. This is 2, right? What about C? Well, C is, do we have a vertical shift? Now, before we do C, let's look at D. D is, has this been shifted up or down? No, it has not, because the axis of this sine or cosine, it's actually cutting at the x-axis. So it has not been shifted up or down. So D is 0. Now about C. First of all, is this a sine or a cosine? Well, we said that the sine starts at 0, 0, it goes up 1, it crosses at 180, and then it goes to negative 1. How is it the cosine? The cosine behaves like this. Let's graph it here. So we have for the sine, as we said, we're going to graph the sine of x. We're going to graph the cosine of x. In degrees, okay? We're going to do it in degrees. So this would be x, y. We're going to have 360 in here, 180 in here, 180 in here, 360 in here. And then we have 1, a negative 1, 1, negative 1. Okay, so the way it behaves is for the sine goes, as we said, it starts at 0, 0, goes up to 1, then it crosses here at 180, and then at 270 it goes to negative 1, and at 360 it finishes, right? While the cosine starts here at 1, it crosses at 90. This is 90, right? This is 90, and this is 270. 90 and 270. So the cosine starts up here, goes crosses at 90, and then goes to negative 1 at 180, and then just goes up, crosses at 270, and it finishes at 1 again. So we have a full cycle, and a full cycle here. Okay? Now, so we go back to here, and we compare, is this a sine? Is this a sine? Let's look at it. Does it start at 0? No, it doesn't. It starts at 2, right? So it looks like it's going to be a cosine because it starts up here. See the cosine here? It starts here. But instead of starting at 1, it starts at 2. But we can model this just putting that a is going to be 2. That's going to be fine. Okay? So again, this is a cosine. Even if it's a cosine, there's no horizontal shift. Okay? So that means that if there's no horizontal shift, C is going to be 0. So now we just come here and we just plug in A, it's going to be 2. This is going to be a cosine for this one, as we said, because it starts up here. And then B is going to be 2, and C is going to be 0, and D is going to be 0. So the function here is going to be 2 cosine of 2x. That's it, in degrees. So that's what I'm going to write down here. Oh, sorry, let's write the y in here. So it's 2 cosine of 2x. I'm going to go for the next one. In B, as you can see, in B, we have a vertical shift. The axis, which would be this one, this axis, this is cutting the sine in half, you see? This is going to be the axis. And here in the axis is when we see that the amplitude, it's the same when we go up or when we go down. How much is the amplitude in here, Mick? The amplitude will be from 5 to 2. So 5 minus 2, that's 3. Yes, Mick, that's 3. So here, so the amplitude is 3. Okay. Now, how much degrees is a full cycle? 90. Are you sure you're looking right, Mick? Let's look. You see here, 120, as we said before, a full cycle in here, the function is going up. Is it here going up again? No, it's going down, right? So if this is going up again. So this would be a full cycle, and a full cycle would be then 120, you see? T, the period is 120. A is going to be 3. B then, again, B is 360 over T. 360 over T, that means it's 360 over 120. Okay. How much is 360 over 120? Well, this is the same as 36 over 12. And then 12, that's 3, right? 12 plus 12 plus 12 is 36. So this is 3. Now B is 3. Is this a sine or cosine? Well, some people get confused here because they think, oh, okay, it doesn't start at 0. Wait. It doesn't start at 0. But you have to look at the axis, right? Look at the axis. So, or maybe here, right? Look at the axis. It starts with the axis. So here has been a vertical shift. So what you have to understand is that the axis now is here, and the sine always starts with the axis. Okay, well, the cosine, it doesn't. So this is a sine. Okay, starts here, the axis goes up, then it crosses the axis, and then it goes down, and then it crosses the axis again. Okay. Now, so we don't have horizontal shift, so C is 0, and we do have vertical shift. The axis has gone up. How much? 2, right? So this 2. So then this means that the function here would be 3, right? We look at A up here. So it's going to be 3. Then B is going to be 3. Again, is a sine. 3x. And then D is 2, plus 2. Okay? I'm going to do one last one, and we'll leave the rest for you guys. So let's look at this one. So first the axis. So just grab the axis. And again, if we want to find the axis properly, we should look at how much is it's the total height, and then divided over 2, right? So it goes from 0 to 5. That means that actually here the axis is going to be at 2.5. That's why we have to look at the height and then divide by 2, so we don't make mistakes. So that means that the axis here, it's just in the middle. So we have to be careful with that. Okay. Now, is this a sine or a cosine? Does it start at the axis? No, it doesn't. It starts down here. So it's not the sine or it's not the cosine, but we can look at something. There's 2 ways of doing this, but maybe we can look here at the shift. I think it's going to be easier for now. So again, how much is A? From here to here, how much is it? It's going to be, Mick? I don't know. Well, this is half, and 2 here, that's 2.5, isn't it? 2.5 or 5 over 2, whatever you like. I like fractions, so 5 over 2 is fine. So B, how much is B? How much is a full cycle? Well, from here to here, we're going to have a full cycle, right? So that means that T, the period, is 720. 720. So we're going to have, again, 360 over T, with the formula from up here. So it's going to be 360 over T. So that's going to be 360 over 720. And actually, this is double than this. So that means that if we simplify, we have a 1 here and a 2 down here. So that's 1/2. Okay, then C. Okay, C, it's the horizontal shift. And if you look at it, if this would be in here, this would be a sine. Go up, right? So this is the shift. So if we move this back here, we can have a sine. Now we have to think if this is positive or negative. This is, and remember, here's where we look at left and right, right? So this has been moved to the right. Because it hasn't been moved to the right, it will be negative. The horizontal shift will be negative. So that means that this is negative 180. Negative 180. So that's C, negative 180. And then D, has this been moved up or down? Yes, it has been moved up, right? Up the axis 2.5, so it's also 5/2. So then this is going to be, and again, it's going to be a sine because it will start here after the horizontal shift, right? So it's y of x is 5/2. That's for A. Sine of, now it's B, 1/2. And then of x minus 180 plus 5/2. Okay, that's pretty crazy, right? Pretty crazy. We can avoid, oh, let's write it here. So this is 3 sine of 3x plus 2, and this is 5/2 sine of 1/2 x minus 180 plus 5/2. Some of my students will actually understand also, because we have done it, that we can express this as a negative cosine, because when we make a cosine negative, it flips. It's just everything. What it's up goes down. What it's down goes up. Okay, so if we flip this will be a positive cosine. If we flip it that way, it will be a negative cosine. So we can also express this as 5/2 cosine. Do you guys see in here? Yeah, see though, right? So then this will be negative cosine of 1/2 x plus 5/2. This will be the same thing. So you can also write it this way. Okay. And I leave the rest for you guys. Remember first to start graphing the axis, okay, and finding the rest. Okay. Have a great day. Bye-bye.